to our channel, Autotech TV. Today we are going to explore how the starter switch works in a car, its importance, common problems it may have, and how to fix them. A starter switch is a device in a vehicle's electrical system used to activate the starter motor, which cranks the engine to initiate the combustion process. It is typically part of the ignition system and can be operated with a key, a push button, or a remote control. The starter switch connects the battery to the starter motor, completing the electrical circuit needed to start the engine. The design of a starter switch typically includes the following components and features. 1. Housing, usually made of durable plastic or metal to protect internal components. Compact and robust to withstand environmental conditions and regular use. 2. Electrical contacts, made of conductive materials like copper or brass. Ensure a reliable connection between the battery and the starter motor when activated. Key slot or button, for manual operation using a key or push button. Modern designs may include proximity sensors for keyless operation. 4. Internal spring mechanism, returns the switch to its default position after activation, e.g. from the start position to on. 5. Terminals or connectors, enable connections to the battery, ignition coil, and starter motor circuit, labeled for proper installation. 6. Safety features, anti-theft mechanisms like coded keys or immobilizers. Prevents accidental activation by requiring a specific input or condition, e.g. pressing the brake. 7. Position indicators for keyed switches. Off, disconnects all circuits. On, powers the ignition and other systems. Start, engages the starter motor. Modern vehicles may also integrate the starter switch into electronic systems such as push-to-start mechanisms, which use sensors and relays for operation instead of traditional mechanical parts. Starter switches are classified based on their design, operation, and functionality. Here are the common types of starter switches. 1. Keyed ignition switch. Description: operated with a physical key inserted into a slot. Positions: off, accessory, on, and start. Common use, traditional vehicles. Advantages: simple and secure with built-in anti-theft features. 2. Push button start switch. Description: activated by pressing a button, usually in keyless systems. Operation: requires a smart key or proximity sensor to detect the key fob. Common use, modern cars with advanced ignition systems. Advantages: convenient and efficient. National 3. Rotary ignition switch. Description: operated by turning a knob instead of a key. Operation: often used with keyless systems. Common use, high-end vehicles and specialized machinery. Advantages: stylish and user-friendly. NAR 4. Toggle starter switch. Description: a flip switch mechanism for starting the engine. Operation: requires flipping the switch to complete the circuit. Common use, industrial machinery, older vehicles, or custom-built cars. Advantages: simple design and easy to install. 5. Foot-operated starter switch. Description: activated by pressing a pedal or button with the foot. Operation: engages the starter motor through mechanical or electrical linkage. Common use: vintage cars, trucks, or heavy equipment. Advantages: durable and requires no hand operation. National number 6. Remote starter switch. Description: operated using a remote control or smartphone app. Operation: sends a wireless signal to activate the starter motor. Common use, aftermarket systems or luxury vehicles. Advantages: allows remote starting and additional features like climate control. Number 7. Magnetic starter switch. Description: uses a magnetic relay or solenoid to engage the starter motor. Operation: completes the circuit when the magnetic field is energized. Common use, heavy equipment and industrial applications. Advantages: reliable and suitable for high current applications. Each type of starter switch is designed to meet specific needs, whether for convenience, security, or industrial functionality. Starter switches can also be classified based on the positions they offer in their operation. These positions determine the functions they control in the vehicle's ignition system. Here are the types of starter switches based on their positions. NAR 1. Two-position starter switch. Positions off, disconnects the electrical circuits, no power to any system. Start, directly engages the starter motor. Use simpler systems like older vehicles, machinery, or equipment. Advantages: minimal design and easy operation. 2. 3-position starter switch. Positions: off, disconnects power to all circuits. On run, powers the ignition system and other essential components. Start, activates the starter motor to crank the engine. Use, common in modern vehicles with more electrical components. Advantages: provides control over both ignition and starting systems. 4-position starter switch. Positions: 1. Off, disconnects all power and circuits. 2. Accessory, powers non-engine components like the radio or lights. 3. On run, powers the ignition system, fuel pump, and other critical systems. 4. Start, engages the starter motor to crank the engine. Use, found in most modern passenger cars and vehicles with complex electrical systems. Advantages: provides flexibility and allows use of accessories without starting the engine. Number 4. 5-position starter switch. Positions: 1. Lock, locks the steering wheel and prevents key removal in some vehicles. 2. Off, disconnects power to the circuits. 3. Accessory, activates non-engine electrical components. 4. On run, powers the ignition and essential systems. 5. Start, engages the starter motor. Use, advanced vehicles with additional security and control features. Advantages: offers enhanced security and multifunctionality. Additional notes: keyless systems, modern push-button or proximity-based systems replicate these positions electronically. For instance, pressing the start button without pressing the brake pedal can enable the accessory or on position. Customization: in industrial applications, starter switches may have fewer or more specialized positions based on specific operational requirements. Each position is designed to manage different stages of the vehicle's ignition process, providing control and functionality to the user. The function of a starter switch is to initiate the process of starting an engine by connecting the vehicle's battery to the starter motor. It controls the flow of electrical current in the ignition system and ensures the engine cranks to begin its operation. Key functions: 1. Completing the circuit, connects the battery to the starter solenoid and motor, enabling the starter motor to crank the engine. 2. Activating the ignition system, powers the ignition coil and other systems required for the engine to start. 3. Safety control, prevents accidental activation of the starter motor when the engine is running. May include interlocks like requiring the brake pedal to be pressed or the gear selector in park or neutral. 4. Switching between modes. For keyed switches: off, disconnects power to the vehicle's electrical systems. Accessory, powers non-engine components like the radio or lights. On, activates systems like the fuel pump and ECU. Start, engages the starter motor. 5. Disengaging the starter motor, automatically disconnects the starter motor from the circuit after the engine starts, protecting it from damage. In modern systems, the starter switch may also include features like keyless entry, immobilizers, and integration with remote start technology for enhanced functionality. Troubleshooting a starter switch involves identifying and resolving issues that prevent the engine from starting. Here's a systematic approach to diagnose and fix common problems. 1. Symptoms of a faulty starter switch: engine does not crank or start. No sound, clicking or otherwise, when turning the key or pressing the start button. Accessories like lights or radio may not work. Intermittent starting issues. Starter motor runs continuously even after the engine starts. 2. Steps for troubleshooting. Check the battery. Problem: a weak or dead battery can mimic a starter switch issue. Solution: test the battery voltage. Should be 12.6 volts or higher. Recharge or replace if necessary. B. Inspect the starter switch connections. Problem: loose or corroded connections at the switch terminals. Solution: tighten or clean the connections and ensure they are secure. C. Test the starter switch. Problem: the switch may be internally damaged or worn out. Solution: use a multimeter to test continuity across the switch terminals. Replace if there is no continuity when in the start position. Check the ignition relay or solenoid. Problem: faulty relay or solenoid can prevent the starter motor from receiving power. Solution: swap the relay with a similar working one or test the solenoid with a multimeter. E. Verify neutral or park position. Problem. Safety interlocks may prevent starting if the vehicle is not in park or neutral. Solution. Ensure the gear selector is in the correct position. Test the neutral safety switch if needed. F. Inspect the wiring. Problem. Damaged or frayed wires can disrupt the electrical circuit. Solution. Trace the wiring from the starter switch to the battery and starter motor. Repair or replace damaged wires. Task G. Test key or button functionality. Problem. Worn out key cylinder or malfunctioning push button. Solution. Replace the key cylinder or button assembly if they are not functioning correctly. H. Examine the steering lock mechanism for keyed systems. Problem. A stuck or damaged steering lock may prevent the key from turning. Solution. Lubricate the lock or replace it if it is faulty. I. Check for security system issues. Problem. Immobilizers or anti-theft systems can block the starter circuit. Solution. Reset the system or consult a professional if the immobilizer is causing the issue. 3. Preventive measures. Regularly inspect and clean electrical connections. Ensure the battery is in good condition. Avoid forcing the key or button if it doesn't respond immediately. Periodically check the starter switch for wear and tear, especially in older vehicles. If the issue persists after these checks, consult a professional mechanic, as the problem might involve deeper electrical or mechanical components. Thank you all for continuing to stay with us. May God protect you. You were with Irene, a teacher of automotive technology, electricity, and electronics. Goodbye.